This file describes how to solve the sixth problem in the diffusion and osmosis problem set. Problems 6 through 8 illustrate basic concepts and skills for using the Nernst equation. This is the simplified version of the equation where Z equals 1, which can be used for monovalent cations such as potassium ions. The cell has a higher concentration of potassium inside than outside. The cell has potassium channels, and the membrane is permeable to potassium. What can we say about the potassium diffusion potential? The diffusion potential is an imbalance in the electrical charge across the membrane due to an ion diffusing down its concentration gradient. 3 millimolar is the concentration of potassium outside the cell. 150 millimolar is the concentration of potassium inside the cell. These are not sensible answers to the question. The diffusion potential will either be inside negative or inside positive. Positively charged potassium ions will leave the cell, moving down their concentration gradient. This will leave an excess of negative charge inside the cell. The solution to problem 6 is choice A. The potassium diffusion potential will be inside negative. The positively charged potassium ions will leave the cell, leaving behind excess negative charge inside. Remember that the diffusion potential is an equilibrium potential. Once the diffusion potential is established, the inside negative charge will tend to draw positively charged potassium back into the cell. There'll be a balance between the tendency of potassium to move back into the cell to reach the negative charge and the tendency of potassium to leave the cell because of the higher concentration of potassium inside the cell. Remember, when the diffusion potential is established, only a very small amount of potassium will have leaked out of the cell.